We've seen plenty of exceptions so far in this course. Java throws an exception anytime we get a runtime error. There are going to be times when you're going to want to throw your own exceptions in the classes that you write. So let's have just a short overview of how to do this. This actually gets a lot easier now that we understand the idea of inheritance. Because Java provides this hierarchy of exception classes that represent, the most commonly occurring exceptions that you might run into. Here's a list of some pretty common ones. Now, if you want to look through these, I bet you recognize them. Java throws an arithmetic exception whenever a program tries to divide by 0. There's a null pointer exception whenever a program tries to call a method on a variable that's not actually pointing at an object. You probably get an array index out of bounds exception whenever the integer in an array subscript, like whenever the element you're trying to index into is less than 0 or is greater than or equal to the array's length. And there's a bunch of other ones too. Right? An illegal state exception, legal argument exception, you can use those to enforce preconditions, to make sure that the input to a method follows whatever rules you're setting. There are other exceptions defined in other packages like java.util, and in general, you're going to determine by yourself which preconditions you want to enforce, and then you're going to choose what kind of exception you want to throw, sort of like a little toolbox of exceptions. This is the syntax to throw an exception. Pretty basic. You just throw, and then you have the keyword new as if we were instantiating a new object. Whatever the exception class name is, for instance, arithmetic exception, and then as a parameter in the exception constructor that you're calling, you pass a string, which is essentially just a message that you want to display. So an example here is if we wanted to enforce the fact that the number, say it's inputted by the user or it comes in as a parameter. If you want to enforce the fact that it must be greater than or equal to 0, you could say if number is less than 0, throw a new runtime exception, and the message we want to store in it is number should be non-negative. So you can see here we're essentially instantiating a new exception object and using the throw statement to propagate it, to throw it back. So maybe a brief overview of how exceptions work would be in order. When you run a program, the computer keeps track of sort of the context of the program. And that includes the chain of method calls, which starts at main, in whatever the main class in your project is, and ends with whatever program is currently running. So when a piece of code in the current method throws an exception, say it found out that some rule got violated, and it uses the throw statement to throw some kind of exception, well, then the computer looks at the code that's immediately surrounding that throw statement for a try-catch statement. We'll learn more about this in just a second. If it doesn't find a try-catch statement, then we're going to return out immediately to the next method up in the call stack. Then we're going to return immediately to the next method in the call stack. Now, in that next method, we're going to look immediately around right where we are to see if there's a try-catch statement. If we don't find one, then we're going to move up to that method's caller and look again. And we're going to do this until we either find a try-catch or until we get all the way up to main. If you don't find any try-catch statement anywhere in this entire process, then the computer is going to stop the program and it's going to show you a trace of all the method calls, the type of exception, what the error message that you gave it was. You've seen this tons of times before. The process of moving back through the call stack looks something like this. If we were to start with main, and then we have a series of method calls, and then here is where we actually hit the error, here's where the exception is thrown, well, then we start working our way back through the trace of method calls, looking for a try-catch statement. If we don't find one, we'll get back to main, and once again, we'll just show that exception and a trace of all the method calls. Now, we saw in the last lecture one way to approach enforcing preconditions, making sure that inputs either to a method or from the user via scanner or whatever actually meet the preconditions that we've set. Using exceptions to do this enforcement is a little bit more of an aggressive way to handle it. So we're going to take a look at what it would look like to actually use exceptions to enforce the preconditions for set score, just as we saw in the last lecture. We know what the preconditions are, so we're going to start by choosing the right exception and describing that in the documentation. We're going to throw an illegal argument exception if either parameter violates our preconditions. Now, because the method is either going to succeed or it's going to throw an exception, we'll make it now return void rather than Boolean. So let's take a look at the method header. We're going to see a summary of the changes that we want to make. You can see the post condition here is just that the test score at position I gets set to the score. And we're just outlining what the exceptions that we're going to throw are and under what conditions we're going to throw them. So we're going to throw an illegal argument exception if I is outside the acceptable range. We're also going to throw an illegal argument exception if the score is outside of 0 to 100. Take a second to look through the code. It looks sensible enough. If I is outside the range, throw new illegal argument exception, and you can see the message we pass it. We'll also check to see if the score is correct, and if it's not, then we're going to throw an argument exception there. And again, we're constructing a string that will be helpful to us if we were to find an error and have to trace through the exceptions that were thrown. And last of all, if neither of those exceptions gets thrown, then we'll actually do what we set out to do and set element I minus 1 to score. A few slides ago, I kept mentioning the try-catch statement as the thing that we keep looking for whenever we are bouncing back through the call stack, looking to see how we should handle a particular exception that was thrown. Using exceptions can actually make your code pretty foolproof. But any client code calling your method still needs to check those methods' preconditions if they don't want to trigger those exceptions and halt their programs with runtime errors. A couple ways to do this. You could just use a simple if-else statement to ask all the right questions about the parameters before you even call a method. Or you could stick the method call inside a try-catch statement. Again, what we were talking about before. A try-catch statement is like a safety net. It lets a client, that is code that's using a particular method that you've written, it lets a client try calling the method, even though its preconditions might be violated, and then it catches any exceptions that the method might throw, and it lets you respond to them, gracefully in a controlled way, rather than just ending the program right then and there. As an example, take a look at this code. It displays the exceptions error message in the terminal window instead of just ending the program. When the setScore method throws the illegal argument exception, the computer passes that exception as a parameter to the catch clause, and the catch clause immediately takes control. Now, this code catches and handles exceptions only of this type, only illegal argument exceptions. But suppose a method can throw two different types of exceptions, maybe an illegal argument exception and an illegal state exception. To catch either one of these, you just use two catch clauses, right? So you have some code that could throw one of two possible methods like you have here, and then you have two catch statements, one for each type of exception that you want to handle in a different way. Now here, we actually handle both of these methods in the same way, but we have catches accounting for both possibilities. The computer is just going to run down the list of catch clauses until we find a match for the particular exception type that we have, and if no match is found, then the exception gets passed up the call chain just as we talked about before. If you want to guarantee that your exception is going to get caught, you can use the highest level in the hierarchy, this generic exception class, which handles any exception type. So it doesn't matter what setScore throws, they're all subclasses of exception, and therefore it doesn't really matter. We'll print it out no matter what. Okay, we'll shift gears for just a moment and cover one little miscellaneous topic. If you've used any of the online Java documentation, you've seen the way it looks for all the standard Java classes. All that documentation is created using a tool called JavaDoc. And you can make the same kind of sort of professional-looking documentation for your own classes as well. Essentially, you're just going to include in your .java files some special commenting syntax that marks the information that's going to appear in the doc pages. We typically mark things like a summary of the class's purpose, method parameters, return values, and exceptions. Those are some common things that we often put into JavaDoc comments. Then you just run the JavaDoc tool, which we'll talk about in just a second, and it's going to turn your comments into documentation. We'll take a look at the student class. We'll take a look at the updated student class, which now has some static constants, it has some exceptions, and will generate JavaDoc documentation for it. The basic syntax for JavaDoc comments is pretty straightforward. We start our JavaDoc comments with a slash and 2 stars rather than a slash and 1 star. We put a comment that describes what the class does between the header and the import statements, if there are any import statements. And any lines that start with the @ sign, they get special formatting in the documentation. We'll see some of those in this example. The key ones to watch for are parameters, return values, and exceptions thrown. This first comment describes the purpose of the class. We didn't have any import statements, so it's just going at the top right now. We can see above these static constants, we've got more java.comments. You can see the 2 stars, and it's describing just what the static constants are for: minimum score, maximum score. Move on, this constructor, great, java.comment, java.comment. Note here above this constructor, we have an @param. So we can see, all right, this is a parameter. It's called nm, and here's what it is, the name of the student. Here we've got 2. A parameter called nm, which is the name of the student, a parameter called n, which is the number of scores. All of those baked into java.comments. More here, java.comments. Inside, we've got parameters for this version of the student constructor. Here, another version of the student constructor, parameters, good. More here for set name, nothing new. You can pause the video and take a look if you'd like. Here for get name, we've got a return value. So inside our java.comment above get name, we use the @return line. So we're returning the student's name. Okay, more parameters here for set score, param. Great, now we've got some exceptions. So we can see this method throws an illegal argument exception, and then we have a message documenting when it throws that type of exception. Here, it throws this kind of exception if this all happens. More along those lines here for get score and get average. Param throws return, great, return. Again, these are all inside java.comments. Good. And finishing it out with our last set of methods. If you've included the java.comments in your own code and you're ready to generate the Java docs, here's all you do. Click project, generate Java doc. You'll need to find the javadoc.exe file on your computer. You might consider searching for it through the file system. I found mine in my Java installation. You can see my path here. I bet it's somewhere similar on your machine. You can also choose here what project, what package, and what classes you're attempting to generate documentation for. And you can decide where the destination will be. Click through, fantastic. And ultimately, if you go to your workspace in the file system or on your flash drive, you should have a folder called docs, and inside there, index.html. If you open that up in a web browser, you'll see your docs as generated by JavaDocs. Your big takeaways for the day. You want to think about when a method should throw an exception. Think about an example. What happens at runtime when a method throws an exception? Here we're talking about tracing through the call stack. How does that exception get handled? Whether through the call stack, looking for a try-catch statement, and so on. How can you use a try-catch statement to control what happens when an exception runs? And just remember those 3 basic tags that you use in the JavaDoc comments to indicate parameters, exceptions, and return values. That's all for today.